Okay, welcome to MBP tutorial. In this video, we'll learn how to create scaling plots in MBP. In addition to the IV curves in the global model fitting process, we'll always need to see the trim plots like VTH versus length, those kind of scaling plots to get a better fitting result of the whole model. Scaling plots in MBP are shown in the IMV. When we open IMV page, there are some default settings inside it. And we can add another screen to show all those plots. For example, if we have VTH versus length for different widths, we can show this trim. But with the default setting, it doesn't cover all the trim plots you will need to use. So in the real case, we'll also need to edit and create our own trim plots. So for those creating processes, we can do that in the script by open script project. And we can see there's the IMV part and different targets or trends, different curves are defined here. And we take the VTH as an example. Normally we have two kind of VTH definition, the constant current method, which is VTH count here, and the other one is the VTH GM, which is this one. And we'll use the VTH constant current method as an example. The VTH can be calculated from the IDVG curve. So we can select the Java algorithm and page name. To page name, we select IDS, VGS for different VBS here, and the restrictions, and also select algorithm class. We can see there are different algorithm class here. The definition of each one can be found in the help file. We select this commonly used one here. In the algorithm parameters, we can see that this icon is used here, and this icon is defined in the IMV constant part. We can see the value is defined here. And we also have the VTH count link, VTH count set defined here. Both of them are calculated and use the constant current method, but difference is that we can see the restriction part is different. For VTH count link, the VDS is minimum value. For the VTH count set, the VDS is max value. And if you don't like those names, you can create other ones. For example, you can create an IMV use VT link. It's a special name. And we can use auto refer because we already have the VTH count lane defined. And we can use auto refer to select the VTH count lane and by page. Because we already have the VTH count lane defined, we don't need to redefine it. We just auto refer it and use a different name. So same as the VTH count set, we can create and rename it as VT set and refer it as VTH count. Sorry, VTH count set. This is the name, and then we can see that both of them are defined. And also, if we want to, when we have the targets defined, we can use the show data table to check the calculated values of each target. And then we can add a graph to this specific target. We suppose we are adding some plots to the link. We use we name it VT lane versus length, and another one VT lane versus width, and added it. So the X will be length Y will be detailing. And the P, we'll leave it there. The hierarchy here is the outside folder, which will show the curve. For example, we can put it IMV, so the new curve will be showing that below the IMV, and can also put it under, we can also add the hierarchy as VTH, so the curve will be shown here. But here I want to add another name. So usually we want we don't want to mix our own target with the default targets from MBP, so we give it a specific name. And after finish, you can preview it from here. You can see some of the, if we have enough data, the trend plots are shown here. And then can go back to the IMV and then apply. And reopen it. You can see the customized one, ETH lens already here. It's already done. You can also add some plots for the VT set. VT set plus lens and VT set plus width. And we can use the same way to edit each graph. Make sure the title, X, Y, and hierarchies are right. And then go back to IMV and apply. We can see the customized part already includes the four graphs we just. We can select each graph to show them. This is how we create scaling plots in the script project and then show them on the IMV part.